So next measurement of time, basically measurement of time not using a stopwatch or clock. Okay, this is measurement of time using a pendulum. Okay, yes, again you have to read this pendulum, but little bit in detail. Okay, so let's say I'm drawing a pendulum. Let's say this is a pendulum. Okay, and this is the length of the string by which the pendulum is hanging. Length of the string means up to this extent. This is the length of the string. And let's say the radius of this bob, this is known as bob, this ball is known as the bob. So if r is the radius of the bob, then the effective length of the pendulum, that is L, equal to L prime plus r. Okay, so starting from this rigid support up to the center of the bob is known as the effective length, or sometimes length of the pendulum. So whenever I talk about the pendulum, you have to understand that this is starting from the rigid support up to the center of the bob. Okay, so this is the length of the pendulum. Okay, and you know that pendulum oscillate like this, you have a oscillate correct. Okay, so all we know that is the for relation between the time period and the frequency, that is from class 8, and we know that is f equal to 1 by t. Again we need this. What is this capital T? This capital T is basically the time period. This is the time period, and this is small f. What is this small f? Yes, right, this is frequency. Okay, so this is time period and this is frequency, and this is the relation between frequency and the time period. Okay, this is the question from third term. Okay, so now it is our turn that how we can measure the time period of a pendulum. Okay, just let me tell you one thing. The time period of a pendulum T, that is given by a formula, that is 2 pi root over L by G. 2 pi root over L by G, where L is the length of the pendulum. And G is the acceleration due to gravity. I know, acceleration due to gravity. And what is its value? 9.8. Now you may ask, sir, can't we use 10? Of course you can use 10 whenever it is instruct to use 10. Okay, but its actual value is 9.8 or 9.81 meter per second square. Or if you want to write in CGS unit, then it is 980. Okay, 980 centimeter per second square, not 98, 980 centimeter per second square. Okay, whatever, just look at here. What is the important thing here? The time period depends upon the length of the pendulum. Okay, and the acceleration due to gravity, but the acceleration due to gravity is constant at a place. Okay, that means acceleration due to gravity is basically a constant quantity. But if you change the height from the surface of the earth, then it may change, but we shall take G as a constant quantity for now. So basically time period is depending upon the length only. That's mean T is proportional to root over L. Okay, so if you increase the length of the pendulum, then the time period will also increase. Increase of time period means the pendulum will become slow. Increase means time is increasing. Time is increasing means it takes more time. Means it becomes slow. Okay, so increase in time period means the pendulum becomes slow, and increase in time period means decrease in frequency. That's mean the time period become fast, the pendulum become faster. Okay, so that is all we need to know from here. Rest of the all I shall show you in laboratory, that exactly how to measure the time period. Just I am now telling you the process. Okay, you just have to take the pendulum here at a position. Okay, and you have to release it. You will find the time period is doing like this. And we know a time period means when it complete a full oscillation. That means starting from here, it will again return here. So the time taken by the pendulum in this case, that is a complete time period. Okay, and you just have to take a stopwatch. You have to switch on the stopwatch. Starting this, you have to start the stopwatch when you are releasing the pendulum, and when it is coming here you have to stop the stopwatch, and then you can find the one time period. But this process is little bit difficult, so what we does, we just take the total time for, let's say, 30 oscillation, means 1 2 3 4 5 like this, 30 total oscillation. For that we shall measure the time. After that we shall divide the total time with by 30. We shall just divide the total time by 30, then you can find the time period with you can time the time period with more accuracy. Okay, it will be more accurate. Let me tell you one thing. Suppose instead of up to this extent you are taking the pendulum up to this, then you are releasing, then it will vibrate like this or oscillate like this. Okay, that doesn't mean the time period will change. Okay, I shall show you. That doesn't mean the time period will change, because this is nothing but amplitude, and time period doesn't depend on amplitude, it only depends upon length. If you increase the length, then the theory is a little bit different. Okay, so this is this thing and this thing you have to know. Okay, no need to worry. Numerical problems may come from here. What type of numerical problem? Suppose are saying that the numerical problem is like that, time period of a pendulum of length 100 centimeter is 2 seconds. Okay, what is the time period of pendulum with length 500 centimeter? This type of problem may come from here. Okay, just pause the video and solve the problem. Is it done? Okay, now I am doing. We have the formula T proportional to root over L, right? So just do it like this, the gas law. T1 by T2 equal to root over L1 by L2. Everything is given. Okay, L1 that is given 100. L2 that is also given 500. Of course, centimeter you have to write. And T1 is given 2 seconds. Just put the values, you have to find T2. Okay, so just solve it. Okay, now look at this. So T1 is 2, T2 I don't know, and this is 100 and this is 500. Just solve this small mathematics. Okay, tell it T2 equal to 2 root 5 second. So this is the answer. Okay, just keep remember one thing. You may tell me, sir, this is in centimeter, means CGS unit. Okay, so no problem, this is CGS unit. You are just making the ratio, so the 0 will cut out. If you take it in meter, then also 1 by 5. Okay, no problem, as you are taking the ratios. Okay. Okay, so next, only one topic is remaining, that is to graph. Okay, graph means, suppose you are changing the length of the pendulum, how its time period will change. You are changing the length of the pendulum, how its time period will change. Okay, just look at this relation. This is not a linear relation. I told you what is linear relation. Linear relation, suppose x is proportional to y, that is linear relation. But let's say x is proportional to y to the power something, and here this is the case. X is proportional to y to the power half. That's mean t is proportional to l to the power half. This half is here. That's mean this is a non-linear relation. Okay, this is a non-linear relation. So of course the line will not be a straight line. So if you just draw a t versus l to the power half graph, okay, so what you will find, the graph will not be a straight line. Okay, rather the graph will be like this. Okay, but instead of t versus L, if you just take it like this, t square versus L, t square versus L graph, just make a square on both sides, t square versus L, then t square versus L graph, it will give you a straight line, it will give you a straight line. Okay, so two graphs are important, so t versus L as well as t square versus L graph. Okay, so t square versus L, that is given in your book, t square versus L, that is given in your book, and t versus L you have to learn, this is t versus L. So this is a t versus L graph for this type of pendulum. Okay, okay, so you have to practice this formula and numericals related to this. Okay, I shall give you the exercise from your book. Okay, okay, so this is the end of the first chapter. Rest of the things we shall do in practicals, that's mean in these things are in detail, and how to measure the time period of a pendulum. Okay, okay, on next class we shall talk about the numerical problems if you wish, unless motion in one dimension, that is chapter 2. Okay, thank you student, you may knock me anytime if you have any problem. Okay, thank you.